Hello children, this was 7th standard science electricity lesson, second video, continuation value. Okay children, take page number 20. Okay, in the last class we have seen about what is an atom, what are all the subatomic particles present in it, and what is the cause for electric current, sources of electric current, everything we have seen. Okay, now we are going to see about electric switch. Okay, so what is meant by electric switch? Electric switch is nothing but, you can see this picture. Yes, so this picture shows the switch which we are used in our home and also in our classes. Okay, so the switches are designed according to their usage, convenience and safety. Yes, all the electric switches are designed according to their usage, convenience and safety, but all of them work on the same principle. So what is the principle? Switch is a mechanical component that consists of two or more terminals that are internally connected to a metal strip. Okay, so what is the basic principle in making switches? Switch is a mechanical component that consists of two or more terminals. Terminals means end. Okay, that are internally connected to a metal strip. Why we are using metal means metal is a good conductor of electricity. Okay children, so commonly used switches are given below. The picture of the switches are given below. So tapping key, toggle switch, illuminated switch, plug key, rocker switch, slide switch. So this you might have seen in different places. Okay children, so switches are differed in size, shape and also the structure based on the usage, where it is used. In industries, in factories and all, the switches will be in a different form. Okay children, next we will see about the circuit diagrams. So what is meant by circuit diagram? So when you draw in the last class and all, we have seen that conventional current flow is and also electron flow, citing with the example of the diagram is battery, connecting wire, bulb, everything. So this battery, connecting wires, bulb, everything we call it as electrical components. What is it? We call that as electrical components. First we will see about electric circuits. So what is meant by electric circuit means, if the bulb has to glow means electricity should be supplied to that bulb. Okay, so from the switch, one end will be connected to the bulb. The other end of the bulb will be connected to the other end of the switch by means of wires. Okay, so instead of drawing battery, bulb as a structure, we are having some symbols to represent the electrical components. Okay, so by drawing this diagram, we call that as circuit diagram. We call this passage of electric current by means of through the wire. By citing with the diagram, we call that diagram as circuit diagram. So electric circuits are made up of the electrical components, 4 electrical components: battery, wire, bulb and switch. Okay children, so battery is an energy source which has a positive terminal and a negative terminal, and the symbol for this battery is given as this example. It's given arrow mark, upside arrow mark it is given, that symbol, one long line and one small line. Okay, long line denotes positive charge, small line denotes negative charge. Okay children, then ordinary horizontal line, it is a symbol for wire, connecting wire. Wire connects the electrical components to one another, usually insulated with a rubber covering. If you see the ordinary electrical wire, you would have seen that electric wire, it will be covered by means of rubber or plastic like that. If you cut that electrical wire, you can see one strip, one string like wire like substance will be present, that is made up of copper. Okay children, usually insulated with the rubber covering. The next one is bulb. Light source consists of metal lead filament, glass bulb, metal casing and metal lip. Okay, the next one is switch. Switch controls the flow of electric current. So this symbol represents, if it is open, the switch is in off position. If it is closed, it is in on position. Okay, so circuit diagram, these symbols are used to draw the circuit diagrams. So the electrical circuits, if you take, it can be closed or open. If the electrical circuit is closed, then the electric current flows in the electric circuit and the bulb lights up. Okay, if the electric circuit is open, no electric current flows in the electric circuit and bulb does not light up. Okay, so example for electric conductors are metals such as copper and iron. Electric insulators are wood, glass, plastic and rubber. Clear, children? Next we will see electric circuit. So what is meant by electric circuit? It is difficult to draw the realistic diagram of the circuit. So the electrical appliances we can see at the home can be drawn using the symbols like this. So the bigger line shows positive terminal, smaller line shows negative terminal, and it is connected to the switch. Now it is in open position, that means it is in off position, and the next that into mark it shows bulb, and A it shows the ammeter to measure the electric current. The instrument used, we call it as ammeter. So in a cell, the longer line denotes the positive terminal and the short line denotes the negative terminal. We shall also use these symbols to show the components in the circuit. So that's type of circuit diagrams, we call it as circuit diagram. So all muscles of our body also move in response to the electrical impulses generated naturally in our body. Next we will see the types of electrical circuit. There are two types of electrical circuits, series circuit and parallel circuit. Okay children, series circuit and parallel circuit. So here in the first example it is given as series circuit. Here two diagrams are given. First diagram it shows the electrical components with the diagram, with the structure. The next diagram with the symbol. So the next diagram is the circuit diagram. Okay children, here one battery is connected to two bulbs. So when the switch is on, two bulbs will glow. Okay children, so this type of circuit we call it as series circuit. Best example for this series circuit is, for the decoration purpose and all, we will put that serial light, no? So that is the best example for series circuit. If the one bulb is got fused, means the other bulb will not work. It is controlled by means of only one switch. Okay children, so we call this circuit as series circuit. So in our school also, two fans will be connected to one switch. If you put one switch, two fans will be working. If you put one switch, two lights will be working. So this type of circuit we call it as series circuit. Okay, so in this type of circuit, the power will be less. The power will be less. The next one is parallel circuit. Here each and every bulb is connected directly to the battery. Okay children, we call this as a parallel circuit. In home and all, we are having one, we will have the switch to control only one fan, one light, like that. If you switch on one switch, one bulb will be glowing. Is the another switch for controlling the fan. So we call this as a parallel circuit. So what are the similarity and differences between series and parallel circuit? So in this diagram we call it as Venn diagram. That is, intersection is there, no? That is the similarities, and differences are given in orange color and blue color. Okay children. So here both the series and parallel circuit, which are all common, energy source and wires are common, which is called energy source, battery. Okay children. Okay, so here first one is series circuit. Already I told, the single loop connection will be there. Bulbs will be, the power will be less. So bulbs will be dimmer, and bulbs share the power. All bulbs go out if one gets out. Okay, then parallel circuit, if you take it, connected by means of branches. Bulbs brighter, each bulb fully powered. All bulbs stay lit if one goes out. If there is any mistake in one bulb, we can replace that bulb. Okay children. The next one, if you see the electrician, always the electrician will use gloves and also rubber chappals when they are doing that work. Why? Means this plastic and rubber are insulators. Insulators means which will not conduct any electricity. When the person is working with the electric power, it should be switch off, and for the safety purpose they are wearing that one. Okay children, next we will see about conductors and insulators. So on the last term itself we have studied about metals and non-metals difference. In that we have said all metals are good conductors of electricity. All metals are good conductors of heat and electricity. So what is meant by conductors means the material which will allow current to pass through it. We call that as the conductors. Okay children, so the next one, what is insulator means the substances which do not allow electric current to pass through it. We call that as insulators. Okay children, so up to this we have seen what are all the things we have seen means electricity. Electric current is the flow of just a recap. Electric current is the flow of electric charges typically through wires, conductors and electric devices. So current is equal to flow of charge. So conventional current and electric current. Direction of conventional current is opposite to the direction of electron flow. Okay children, so water current versus electric current analogy. Water current in a river is given and also electric current in a wire is given. Okay children, and next one we have seen that circuit. If the circuit is open, the bulb will not glow. There is no flow of current. If the circuit is closed, there is a flow of current and the bulb will glow. So in series circuit, both the bulbs are connected to the battery. Parallel circuit, each and every bulb is connected directly to the battery. Okay children. So let us imagine that we have a metal in the form of wire. When a voltage is connected across the ends of the metal wire, the free electrons drift in one direction. So a really good conductor is one that has lots of free charges, while those who don't have enough free charges would not be a good at conducting electricity. So we can say that they would be poor conductors of electricity. So metals are good conductors of electricity. Why we are telling like that means metals will have free charges. Okay children, poor conductors of electricity means it is having less number of free charges. Okay, and the conductors I explained everything now. The next one, insulators. Insulators also, this basic thing if you understand, that is enough children. Okay, so here it is elaborately it is given, no need to confuse yourself. The next one, wires. If you take wires are made up of copper, an electrical conductor which have very low resistance. So copper wires are used to carry the current in households. These wires are in turn enclosed in electrical insulators or materials of high electrical resistance. That is, it is covered by means of insulative material. These materials are usually made up of flexible plastic. Next we will see the important thing, effects of electric current. So what are all the effects of electric current means? There are three main effects of electricity. First one is heating effect. Second one is magnetic effect. Third one is chemical effect. So heating effect you can understand easily. So here what is meant by heating effect means when an electric current passes through a wire, the electrical energy is converted into heat. So in heating appliances, the heating element is made up of materials with high melting point. Okay children, so an example for such material is nichrome. So what is nichrome is very very important, an alloy of nickel, iron and chromium. Together we call that as nichrome. Okay, so here the insulated element is in turn placed in a looped tube made up of good heat conductor. This heating element nichrome is covered with a layer of electrical insulation. Okay children, so the heating effect of electric current has many practical appliances, that is electric bulb. After some time, if you touch the bulb which is glowing for a long time, you can observe that heat. Geyser means water heater. Iron box, electrical energy is converted into heat energy. Immersible water heater are based on this effect. So these appliances having heating coils of high resistance. So generation of heat due to electric current. Okay, generation of heat due to the passage of electric current, we call that as heating effect. So this heating effect is applied in water heater, Okay children, water heater, iron box, best example. So what are the factors affecting heat of electric current means electric current, resistance and time for which the current flows. It depends on three factors: electric current, resistance and time for which the current flows. So next one, what is electric fuse? It is very important. So electric fuse is a safety device. Electric fuse is a safety device which is used in household wiring and in many appliances. So this electric fuse has a body made up of ceramic and 2 points for connecting the fuse wire. It is made up of, the outer body is made up of ceramic and inside two metal rods will be placed. Okay, the fuse wire melts whenever there is overload of the current in the wire. Basically these two plates are connected by means of a wire. When current is allowed to pass through this fuse, then it is a good conductor. That metal plates are good conductors, so the electricity will be flowing through the electric circuit. If there is a high voltage, that time what will happen, the wire which connects that both the ends will be getting melted. Okay, so what happened? The connection will be stopped. Okay, when it starts to melt, there will be no connection between the two rods, so the passage of electricity will be stopped. That is the best usage of electric fuse. So this breaks the circuit and helps in preventing damage to costly appliances and to the wiring. So in electrical devices, glass fuse is nowadays used. There is a small glass tube in which lies in the fuse wire. So the next effect is, now we have seen the heating effect. The next one is MCB, miniature circuit breaker. This is also nowadays we are using in AC and all. Okay, AC and all. So automatically if there is a high voltage, it will shut down. Okay children, the next effect is magnetic effect of electricity. So the magnetic effect, this is explained by means of giving the activity 5. You have to take iron nail, battery and switch and also wire. Take around 75 centimeter long piece of insulator flexible wire and an iron nail, say about 8 to 10 centimeter long. Wind the wire tightly around the nail in the form of a coil. Connect this through free ends of the wire to the terminals of a battery. So place the some pins near the end of the nail. So now if the switch is on, what will happen? When the switch is kept in position, the pin starts to cling to the end of the nail. Okay, so when the electric current is switched off, the coil generally loses its magnetism. So such coils are called electromagnets. So you know what is the important property of magnet? Opposite poles attract each other and also magnet will attract iron things, isn't it? So here we are taking one iron nail and it is connected, coiled by means of electrical wire and it is connected to a battery. One end is connected to a battery, another end is connected to a switch. When the switch is on, the current will be flowing through the iron nail and it starts to cling. Okay, so this is the, when the passage of electricity is stopped, the properties also, then iron nail loses its magnetic power. So this type of magnet we call it as electromagnet. So when an electric current passes through the iron nail, okay, or a metal nail or any metal, the metal will attract the iron particle. That means the metal will become a magnet. We call this power as a magnetic power. So application of magnetic effect. So application of magnetic effect of electric current, that is electromagnet. So magnetic effect of electric current has been used in making powerful electromagnets. So what is meant by electromagnet means when electricity is passed through the metal wire or metal strip, the metal will act as a magnet. We call this as the electromagnet. So electromagnets are also used to remove splinters of steel or iron in hospitals dealing with eye injuries. So electromagnets are used in many appliances. Where and all it is used means in electric bell, cranes and also in telephone. So let us know how the magnetic effect of electric current is applied in telephone. So in telephones, a changing magnetic effect causes a thin sheet of metal to vibrate. Yes, so the diaphragm is made up of metal that can be attracted to the magnets. So the diaphragm is attached to the spring that is fixed in the earpiece. So when a current flows the wires, the soft iron bar becomes electromagnet. Third one, the diaphragm becomes attracted to the electromagnet. Okay, diaphragm, when the it attains the quality of electromagnetic power, then the diaphragm becomes attracted to the electromagnet. So as the person on the other end of the line speaks, his voice causes the current in the circuit to change. So this causes the diaphragm in the earpiece to vibrate, producing the sound. Okay children, the next important thing is chemical effects of electricity. So chemical reaction happens when electricity passes through various conducting liquids. So this is known as the chemical effects of electricity. You will learn this in detail in your higher classes. That is very important subject. The content will be huge content, so you will be studying this in the higher classes. Okay children, I hope you understand this lesson well. Okay children, so you go through this. This is very important lesson. Okay children, with this I'll stop this. Thank you children.